Hi everyone, and welcome to the Mat 211 review of random variables, discrete and continuous. So a pair of fair distinguishable dice are rolled. X is the sum of both numbers facing up. Find the probability distribution of X and draw the resulting histogram. So the first things we want to do is we want to determine all of the different ways that X can be calculated. We know that our dice are distinguishable, so therefore we want to treat, if like the first one gets like a 1, second one gets a 2, we want to treat that differently than if the first one gets a 2 and the second one gets a 1, since they're distinguishable. So we can do this by first creating a table of the possible results of these two distinguishable dice. So let's make this black so we can use all our colors. There we go. So we'll do table here. And we're going to have, each of them are die, so each individual die has 1, 2, 3, 4, 5, or 6 as its possible outcomes. So we're going to have a 1, 2, 3, 4, 5, and 6 for our first die, and a 1, 2, 3, 4, 5, and 6 for our second die. Now, we want to put inside this table, we want to put the different values that are possible of X from each of these combinations. So if we have 1 and 1, so our first die is 1, our second die is 1, then we're going to have a 2 here for X. Similarly, if we have a 2 for our first die and a 1 for our second die, we'll have a 3. And we can go on filling out the table like this. We'll have a 4 here, a 5 here, a 6 here, and a 7 here. If we look at our second column, well, we'll have a 3 here because we have 1 for our first die and 2 for our second die. If we have 2 and 2, we have 4, and then 5, 6, 7, and 8. Same again for 3. We're going to have 4, 5, 6, 7, 8, and 9. For 1 and 4, we have 5, then 6, 7, 8, 9, and 10. For 5 and 1, we'll have, let's actually move that 5 over a little bit. Running out of room here. Put him over here. There we go. That's a little better. So for 5 and 1, we'll have 6. We'll have 7 for 5 and 2, or for 2 and 5 rather. And then 3 and 5 is 8, 9, 10, and 11. And then last for 1 and our 6 here, we have 7, then 8, 9, 10, 11, and 12. So those are all the different possible outcomes of X for all of our different combinations of our two die. Clean up our little marks here on our table. There we go. All right, so the next thing we want to do, first, we want to figure out what the cardinality of our sample space is. So our sample space for X is going to be all these different possible values for X, including repeats, since the repeats are generated from different pairs of values for our two die. So notice that there are 6 possible outcomes for our first die, times 6 possible outcomes for our second die, and that's going to be 36. And if we call our sample space X, then this is equal to the cardinality of S, or cardinality of our sample space. So we know when we calculate our probabilities, since these are fair die, so every possible arrangement is going to have 1 over 36. It's going to all have the same probability. So each possible combination is going to be 1 over 36 here for, you know, for 2 here, this 3 here, and then another one for this 3 here, and so on and so forth. So the next thing we want to do is calculate all of our probabilities for our different values of x. So that's different. Now we're going to be determining how many different ways we can get each of these numbers. And we see that x can vary from 2 all the way up to 12. So we'll use a table to determine this, and this table will be our probability distribution. So let's make a little table here. And let's actually move that a little higher because I'm going to run out of space otherwise. Put this up here. There we go. And we'll make a very curvy line down. Good enough. And let's call little x, which I'm going to mark with this kind of curly x here. Let's call that our, you know, our variable for any value that our big X is assigned to. So if, you know, we roll the dice once and we get a 1 and a 2, then our little x is the actual value of 2 here. And we're saying that our big X took that value of 2. So we want to know what the probability of big X equaling each of our little x values is. So we'll put our 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and it looks like we'll have to go to the yellow here, 12. And that'll be all of our different possible values of our x. So now we just need to count up all the different ways that each of these can be achieved. So we'll maybe draw these in some colors to make it obvious. We first have this 2, and there's only one possible way to get to 2. So out of our sample space, 36, out of 36 different options, there's only one possible roll of our 2 die that will give us a 2. So we know that the probability of being 2 is 1 over 36. Next, we have the probability of, let's do this in this color, being 3 here. So we have 2 different ways that we could have a 3. So that means that our probability of being 3 is 2 over 36. And I know I could reduce this fraction here, but I'm gonna leave it as is for right now, just because it'll make doing our histogram a little easier in terms of drawing it. So now we want to look at the probability of being 4. So we've got 3 different ways to be 4. So we have 3 over 36 here. Then for 5, we have 4 different ways that we could be 5. So we'll have 4 over 36. For 6, we'll have 5 different ways that we could be 6. So we'll have 5 over 36 here. And let's see, we'll use this green. For 7, we've got, looks like 6 different ways that we could be 7. So 6 over 36. And now we'll start going back down in numbers as we kind of pass our diagonal here. So there's a pink here. We have 5 different ways that we could be 8. We have 4 different ways that we could be 9. And we have 3 different ways that we could be 10. And 2 ways that we could be 11. And lastly, 1 way that we could be 12. So this is our probability distribution here. So that part's done. Now we want to draw, we want to represent this probability distribution as a histogram. So we want to draw the resulting histogram. So notice that we can go as low as 1 over 36. We go to that twice, and as high as 6 over 36. So let's draw our histogram here. And this will be 1 over 36 here, 2 over 36, 3 over 36. This is going to be probably horribly not to scale, but you get the idea. 4 over 36, 5 over 36, and lastly 6 over 36. Then we have 1. So we don't want to combine these like probabilities because they're not the same. So actually we don't have 1. We start at 2. So we can't say that, count, this one and this one together. We want to represent those separately since they're different outcomes of our x variable here. So this is going to be our x, and this is going to be our probability of our x. So we'll have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 as our various possible outcomes of our big X. And now we can just draw in all of our bars to correspond to each of our probabilities. So we'll start with our 2 here. We have 1 over 36, so got a 1 over 36 there. Then we'll go to our 3 here. We've got 2 over 36, so that'll come up here, look something like that. Shade it in to make it look nice. We have 3 over 36 for our 4. So there we go. Shade that guy in a little bit there. We have, let's see, 4 over 36 for our 5. There we go. Hard to draw with tablets. All right, and then we have, for our 6, we have 5 over 36. So something like that. There we go. Then for 7, we have 6 over 36, so that's our maximum value here. So there we, oops, that's not straight at all. There we go. Good enough. It was colored in so you won't notice as much. There we go. All right, and now we can start going back down. So 8 is 5 over 36. There we go. And 9 is 4 over 36. Ten is 3 over 36. Just reading off my table here. Eleven is 2 over 36. And 12 is 1 over 36. Again, back down to 1 over 36. And there we go. So this, I just wrote a P here, but what this is P of big X equals our little x value here. So all the different probabilities that it can take. So it's the same thing as, in our table here. And this is going to be our big X variable. So that's it. We have our probability distribution here. And we have our resulting histogram here. So we're all done. Before I go, I just want to remind you all that if you're looking for any additional tutoring or academic support at ASU, you can go to the Tutoring Center's website, tutoring.asu.edu, to find all of our resources. Additionally, if you're looking for tutoring services for your specific course, you can use our tutor search tool, which you can find on our main website page here, or by going directly to the tool at this full link here. So thanks so much and have a great rest of your day.